Students, today we will discuss some important questions and which are expected in different entrance exams from 4th year group, what we call it as carbon family. This is the question number 1. Which is not the property of diamond? A. It is insoluble in all the solvents is given. Yes, it is insoluble in all the solvents. Then isomer of graphite. But see, diamond is not isomer of graphite. This graphite and diamond are actually allotropes of each other. Allotropes of carbon. The purest form of carbon, we agree. Carbon is, this diamond is actually purest form of carbon. Among all the allotropes, it is one of the purest form of carbon. It is oxidized with a mixture of potassium dichromate and sulfuric acid at 200 degrees centigrade. Yes, diamond whenever reacts with acidified potassium dichromate, there is a choice of oxidation to produce carbon dioxide. Therefore, option B, it is an isomer of graphite. It is not the isomer. This is actually diamond and graphite. Both are allotropes of carbon. Therefore, question number 1, answer is B. Question number 2, diamond and graphite both are made of carbon atoms. Diamond is extremely hard, whereas graphite is soft. This is because diamond is a hard substance and graphite is what? Soft substance. Both are actually allotropes of carbon, both are made up of carbon. What is the reason behind it? Coming to option A. The chemical bond between any two carbon atoms in diamond are actually stronger is given. Between two carbon atoms, the bond is stronger. Coming to second, diamond is ionic whereas graphite is covalent. See, diamond and graphite both are actually covalent compounds only. Simply these are non-polar, these are not ionic, these are covalent compounds. Covalent, not compound actually, covalent substances. It's better to say covalent substances, not ionic substances. Each carbon atom in diamond is chemically bonded with strong bonds to 4 neighboring carbon atoms, while graphite has a layered structure. Yes, in the case of diamond, each carbon atom is linked to 4 neighboring carbon atoms, the strong covalent bonds, sigma bonds, like this. Strong sigma bonds in a tetrahedral geometry. But to talk about graphite, graphite is having actually a layered structure. Hexagonal layers are there in graphite. This is one of the layer. Another layer you take. These are actually layers of graphite. The layers are held by weak van der Waals force of attraction. The distance also very weak. Distance between the layers, and they are held by weak van der Waals force of attraction. Therefore, graphite is actually soft. Coming to option D, certain atoms in diamond are smaller in size. No, all are actually carbon atoms. How can they be smaller? All are having same size. So, diamond and graphite both are made up of carbon and carbon atoms. Diamond is hard, graphite is soft. Only the carbon atoms are linked to 4 neighboring carbon atoms with strong covalent bonds. In the graphite, graphite is actually layered structure. In between the layers, weak van der Waals force of attractions are there. Therefore, that is soft. That is the correct answer. Therefore, question number 2, C is the answer. Each carbon atom in diamond is chemically bonded with strong bonds to 4 neighboring carbon atoms. But graphite is what? Layered structure. Therefore, it is soft. So, question number 2, answer is C. Question number 3, which form of carbon is used in making boot polish, printing ink, paint and black varnish? A is bond black, B is graphite, C is gas carbon, D is lamp black. See, which of these particular allotropes of carbon is used in the preparation of a boot polish, ink, black ink, etc. Bond black, there is no such carbon actually, bond black. Coming to graphite. Graphite is not generally not used to make inks. Generally, graphite is used to act as what? A lubricant, and also it is also used in the preparation of lead pencils. Gas carbon. See, gas carbon is actually conductor. Therefore, gas carbon is generally used to make electrodes. Coming to lamp black. Lamp black, if you talk about lamp black, this particular lamp black is actually a fine powder of carbon. This is generally used in the preparation of what? Boot polish and black ink, etc. Therefore, question number 3, answer is D. Question number 4, thermodynamically most stable form of carbon is A. diamond, B. coke, charcoal and graphite. See, graphite is actually thermodynamically more stable because its free energy of formation is less than diamond. Graphite formation, the free energy of formation is less than diamond. Therefore, among this particular diamond, coke, charcoal and graphite, thermodynamically graphite is actually more stable. Therefore, question number 4, answer is D. Question number 5, carbon and silicon belong to 4th A group, that is or 14th vertical column. The maximum quantity number of carbon in commonly occurring carbon is only 4, but whereas that for silicon is 6. This is due to A. large size of silicon, B. availability of vacant d orbitals in silicon, C. more electropositive nature of silicon, D. silicon being vulnerable to attack by nucleophilic reagents. Generally, atom is actually forming coordinate number 6, atom is not forming coordinate number 6. Suppose CCl6 generally we won't find, but generally we find CCl6. CCl6 is not generally found, but SiCl6 minus 2 is there. If you talk about carbon and silicon, generally coordinate number 6, there should be hybridization sp3d2. sp3d2. If the carbon atom is not carrying vacant d orbitals, then it cannot form a compound with coordinate number 6. Therefore, CCl6 doesn't exist, SiCl6 minus 2 exists. Therefore, here carbon is not capable of forming compound with coordinate number 6, but silicon is capable of forming. Only the reason is presence of vacant d orbitals in silicon and absence of vacant d orbitals in carbon. Therefore, question number 5, answer coming to be B. Question number 6, least stable hydride is methane, plumbane, silane, germane. See, whenever a hydride stability is coming, see that how far the central atom is smaller in size and what is the bond length. The bond length is big, the bond energy will be less. Therefore, generally that particular hydride, the compound is found to be less stable. Therefore, among this particular, see, carbon, silicon, germanium, lead. Yes, top to the bottom atomic size is increasing, lead atomic size is big, then lead to hydrogen, the bond length will be little greater. Carbon to CH bond, SiH bond, GEH bond you take, and PbH bond you take. The PbH bond is found to be little longer, bond length is more. What is bond length is more, the bond energy will be less. Therefore, plumbane will be least stable among this. Therefore, question number 6, plumbane is the least stable hydride. So, question number 6, answer is B. Question number 7, which among the following has linear structure? See, structures of different molecules and their hybridization should be thorough, because on structure and hybridization many questions are coming in the different entrance exams. Now we talk about the first one, C3O2. This is carbon suboxide. Next one, N2O5, NO2, SO2. These are the answers. You should know all these particular structures and hybridations. Still, carbon suboxide is actually, this is the structure of carbon suboxide. N2O5, this is the structure of N2O5. N2O5. N-word is actually angular again. The structure. S-word is also angular. See, among all these you can easily understand carbon suboxide C3 is a perfectly linear molecule. Therefore, question number 7, answer is A. Question number 8, which melts in boiling water? Gunmetal, woods metal, monel metal, bell metal. Gunmetal is actually it is copper, zinc and tin. Copper, zinc, tin are there. Copper, zinc, tin are there. And coming to this particular woods metal is actually cadmium is there, tin is there, cadmium, tin and bismuth are there. Woods metal. Monel metal, copper and nickel. Bell metal, copper and tin. Among this particular, you see cadmium, tin and bismuth. All the metals are having actually less melting points. They are more volatile in nature. Which one? Cadmium, tin and bismuth. Whenever they are forming alloy, still their melting point is very less. Low melting alloy among all these is what? Woods metal. So it is actually soluble, which melts. It is actually melts in boiling water because its melting point is very less. Therefore, question number 8, answer is B. Question number 9, which does not exist. See, SnCl6 minus 2, GeCl6 minus 2, SiCl6 minus 2, CCl6 minus 2. Just now we have dealt a question, we actually discussed about a question, why carbon cannot form coordinate number 6, why silicon can form coordinate number 6. Similar to the case here, the case of tin, germanium and silicon, all the three are actually carrying vacant d orbitals. Vacant d orbitals are there, vacant d orbitals. But in the case of carbon, there is no vacant d orbitals. As there is no vacant d orbitals, carbon cannot extend its coordination number to 6. Therefore, question number 9, CCl6 minus 2 cannot be formed, not existing at all. Therefore, question number 9, answer is D. Question number 10, the CX bond energy order for carbon tetrahalide Cs. Order for carbon tetrahalide Cs. All carbon only given. CF4, CCl4, CBr4, CI4 you take. In all these cases, carbon is what? Common atom. But wherever fluorine is there, the bond length is less. Wherever chlorine is there, little greater. And again bromine, and again iodine. We are clearly observing carbon to fluorine bond length is less. Wherever the bond length is less, then bondage will be more. Therefore, CF will be definitely having greater bond strength than CCl4, CBr4, CI4. Therefore, the CF4 is greater than CCl4, CCl4 is greater than CBr4 and greater than CI4. This is actually order. Therefore, question number 10, answer is A. Question number 11. Hot and constant HNO3 react with carbon to form A CO2, B CO, C C6H5 COOH, D is what? NO2 plus CO2. Let us say simply carbon plus hot and concentrated HNO3 you take. Then you are getting 4NO2. Here you are getting NO2 and carbon dioxide, C4NO2 and CO2, 2H2O. So these are the products you are getting. Let us see the products and the answers. CO2 only? No, only CO, and benzoic acid is given. Then NO2 plus O2. So both are the products. Therefore, question number 11, answer is D. Question number 12, among the following, the hardest substance is peat, lignite, graphite, anthracite. See, peat, lignite, anthracite. Peat, lignite, anthracite, these are actually forms of coal. But graphite, you see, graphite is actually soft substance, leave it aside. Talk about peat, lignite and anthracite. These are the forms of coal. Among this particular coal, different forms, anthracite is little hard substance. Therefore, hardest among these is anthracite coal. Therefore, question number 12, answer is D. Question number 13, man dies in atmosphere of carbon monoxide because A. combines with O2 present in the body to form CO2. B. reduces the organic matter of tissues. Combined with the hemoglobin of blood, making it incapable of binding O2, dries up the blood. See, generally, whenever you are inhaling carbon monoxide, hemoglobin molecules in the blood, hemoglobin, forming a highly stable carboxyhemoglobin, carboxyhemoglobin. Look here, this particular carboxyhemoglobin is nearly 300 times stable than oxyhemoglobin. Stable than oxyhemoglobin. Once carboxyhemoglobin is formed, then the hemoglobin molecules losing their capacity to bind with oxygen. They cannot bind with oxygen when this particular carboxyhemoglobin is formed. Therefore, oxygen supply to the body is completely stopped. It will lead to death. Therefore, question number 13, what is given? Man dies in atmosphere of carbon monoxide because this combined with the hemoglobin of blood, making it incapable of binding with oxygen. So, question number 13, answer is C. Question number 14, incomplete combustion of petrol or diesel oil in automobile engines can be best detected by testing the fuel gases for the presence of. How we test this particular question number 14? How we test incomplete burning of petrol and diesel in the engine? See, wherever diesel and petrol incomplete burning of any fuel generally produces carbon monoxide. Incomplete burning of any fuel generally results in the formation of carbon monoxide. Yes, petrol and diesel are actually burning less, not completely undergoing combustion, release more amount of carbon monoxide, which is harmful once they are coming into the atmospheric air. Therefore, CO plus H2O, option A, B is CO, C is NO2, D is what? SO2. This CO presence is more in the exhaust fumes of the diesel engine or petrol engine. Then that will, we can say that the petrol or the diesel is completely burnt, not completely undergoing combustion. Therefore, question number 14, answer is B. Question number 15, CO2 is obtained by heating. A. Sodium carbonate, B. Potassium carbonate, sodium bicarbonate. None of this. See, either you take sodium carbonate and potassium carbonate, they are actually stable substances. Only the sodium carbonate on red hot heating, red hot. This particular potassium carbonate also, yes, it is more stable still, On red hot heating only you are getting carbon dioxide. And sodium bicarbonate on little heating, it simply decompose to produce sodium carbonate plus CO2 plus H2O. So CO2 is obtained by heating. So these are all actually producing on heating carbon dioxide, we agree, but these are on heating red hot. Red hot heating means you have to go beyond 1000 degrees centigrade like that. Therefore at normal temperature sodium bicarbonate easily decompose producing CO2. Therefore question number 15, answer is C. Question number 16, aluminum carbide reacts with a dilute HCl to give. Dilute HCl means there will be water, let us say it is acid hydrolysis. Aluminum carbide, answer given as what? Acetylene, ethylene, methane and ethane. Let us see aluminum carbide, you might be knowing the formula Al4C3. This is acid hydrolysis. What is given is what? Dilute HCl is given. Dilute HCl, therefore water will be there in that, undergoing hydrolysis, producing 4 AlOH taken thrice plus 3 CH4. Dilute HCl. So water involving in the acid hydrolysis, you are getting what this particular methane gas. Therefore aluminum carbide on hydrolysis produce methane, and this aluminum carbide also comes in the methanide as it is producing methane gas. Question number 16, answer is C. Question number 17, the greatest percentage of CO is in coal gas, producer gas, water gas, oil gas. See, talk about coal gas is actually a mixture of hydrocarbons. Methane is there and other hydrocarbons are there, coal gas. I agree, carbon CO is also there, but little percentage. Coming to producer gas and water gas. Producer gas is actually CO plus N2. Water gas, CO plus H2. The percentage of CO in producer gas is very less, but the percentage of CO in water gas is more, it is nearly 40%. This is 40%, this is near about 50%. These are the percentages. Here in this particular producer gas, CO percentage is still less in comparison to water gas and oil gas. Oil gas is actually carrying again mixture of hydrocarbons, very less amount of carbon monoxide may be there. Therefore question number 17, more percentage of carbon monoxide is there in water gas only. Therefore 17, answer C. Question number 18, which statement is false? Let us see what which is actually a false statement. A, water gas is a mixture of hydrogen and carbon monoxide. Water gas is a mixture of hydrogen and carbon monoxide. We agree, water gas, CO plus H2. So okay, producer gas is a mixture of carbon monoxide and nitrogen. Yes, producer gas is a mixture of CO plus N2. It's also correct. Water gas is a mixture of water vapor and hydrogen is saying. Water vapor means water and H2. Natural gas consists of methane, ethane, gaseous hydrocarbon. Yes, we agree. Natural gas is actually mixture of hydrocarbons. Mixture of hydrocarbons. Then which statement is false? We require the false statement among this. Then what is saying? C, water gas is a mixture of water vapor and hydrogen. This is not correct. Therefore question number 18, answer is C. Question number 19, water gas cannot be prepared by continuous process because more coke must be added from time to time. B, furnace must be allowed to cool occasionally. C, it cannot be manufactured without producer gas. D, the reaction ceases when coke is too cool. Coke is too cool. This particular talking about water gas. Water gas is actually produced by this particular a furnace we take. Then we are putting here coal or coke. and from one side we are actually passing steam, the other we are passing actually dry air. Dry air we are passing. The furnace, this is actually water gas, CO plus H2. What is actually mechanism here? While producing this particular water gas, you have to pass steam through red hot coke. Actually, red hot coke. Once you are passing steam, definitely the red hot coke is actually cooling down itself because you are passing steam. Therefore, for 15-20 minutes like that, you have to pass steam and get the water gas. While passing this particular steam, it is actually cooled. Okay, then you have to make it again red hot. Therefore, again you have to pass dry air. So occasionally, this you have to pass steam and again dry air, steam and dry air, steam and dry air, and you have to with certain intervals of times you have to pass steam and again dry air. By that only you have to get this particular water gas. If you are continuously passing steam, that cool is becoming cold and you will not get water gas. Therefore, with certain intervals of time you have to pass steam and again dry air to make the coal or coke continuously red hot. Therefore, question number 19, what is given is the reaction ceases when coke is too cool. Therefore, you have to make it again red hot. Therefore, question number 19, answer is D. Question number 20. The structure of hybridization of silicon tetramethyl silicon is SiCH3 taken 4 times. Bent sp, trigonal sp2, octahedral sp3d, tetrahedral sp3. See, look here, this particular SiCH3 taken 4 times. The structure of the molecule is tetrahedral CH3, CH3, CH3 and CH3. This is perfectly tetrahedral with sp3 hybridization. Let's go to the bent sp, trigonal sp2 and octahedral sp3d and tetrahedral sp3. Therefore, question number 20, only it is tetrahedral with sp3 hybridization. Tetrahedral with the sp3 hybridization. Therefore, question number 20, answer is D. Question number 21, asbestos is chemically. So remember some of the chemical formulae. It's better, it's easy to answer such questions. Silicate of calcium and magnesium, calcium aluminosilicate, magnesium aluminosilicate, calcium silicate plus calcium aluminate. This particular asbestos is calcium and silicates of calcium and magnesium. What is the chemical formula of asbestos? See here, Ca, Mg3, SiO4, SiO3 taken 4 times. SiO3 taken 4 times. This is actually formula. Then you can write as CaSiO3, 3Mg SiO3. Either way you can write, both are one and same. The actual silicate of what? Calcium and magnesium. So question number 21, answer is A. Question number 22, which is formed when SiCl4 vapors are passed over hot magnesium. A is given out SiCl2 MgCl2, B is Si plus MgCl2, C is Mg2 Si plus Cl2, D MgSiCl6. Now, SiCl4 react with what? Magnesium. Look here, magnesium is a reducing agent. It reduces silicon tetrachloride to silicon. Therefore, see silicon plus 2MgCl2. Therefore, question number 22, let us see the option B. silicon plus MgCl2. So 22, answer is B. Question number 23. Silicon carbide is used as here dehydrating agent, abrasive, solvent, catalyst. Silicon carbide is one of the hard substance. Silicon carbide is SiC is a hard substance. Fine powder of this particular generally used as polishing material for glass, diamond, metals, etc. Therefore, it is actually used as abrasive. Generally used as abrasive. Therefore, question number 23, answer is B. Question number 24. Purest form of silica is, see first one, quartz, flint, sandstone, kieselguhr. These are the answers. You see, quartz is actually carrying only SiO2. Quartz carry only SiO2. This is actually purest form we can consider. Coming to flint, flint is actually flint glass. It is not simply silica, flint glass. So it is carrying many impurities along with silica. Coming to sandstone, whatever the sand we are getting, sand is nothing but silica, SiO2 we agree, but the sand is carrying many impurities. Kieselguhr, kieselguhr is actually siliceous stone with a siliceous stone with a sea insects. Siliceous stone with some sea insects. This is actually kieselguhr. Therefore, question number 24, purest form of silica, nothing but only quartz. Therefore, question number 24, answer is A. Question number 25, Pyrex glass is a mixture of, see different flint glass, Pyrex glass, different type of many different varieties of glass is there, but the glass compositions you have to remember. Pyrex glass is actually made up of sodium borosilicate and barium borosilicate. Sodium borosilicate and barium borosilicate actually mainly composition of Pyrex glass. It is given as sodium silicate and calcium silicate, sodium silicate and lead silicate, sodium silicate and aluminum borosilicate. So Pyrex glass is actually carrying sodium borosilicate and barium borosilicate. So question number 25, answer is A. Question number 26. A potter wishes to make a deep blue glaze. He wanted to make a dark blue colored pot. Which one of these available chemicals should be mixed? Iron oxide, Fe2O3 or FeO. This actually gives brown. Cuprous oxide, Cu2O. This generally gives red color. Cobalt oxide, yes, cobalt oxide gives blue color. Nickel oxide, black. These are the colors. Many components are used to get different colored glass, but those components and which are giving a particular color, many are there, you have to remember. Whatever there in the question that I mentioned, but blue color you want, then you have to put only cobalt oxide. Question number 26, answer is C. Question number 27, water glasses. Calcium silicate, sodium silicate, magnesium silicate. So among the different silicates, Na2, SiO3 is known as water glass. It actually sets to a water-like precipitate, water-like transparent precipitate. Therefore, it is known as water. Na2 SiO3, commonly known as water glass. Therefore, question number 27, answer is C. Question number 28, which is not used as pigment in paints. One is lead dioxide. White lead, you know white lead is basic lead carbonate. This is white lead. Lead chromate, PbCrO4, Pb3O4, red lead. Which is not used as a pigment in paint. Generally, lead dioxide is not used as a pigment because it is generally used in a match industry. In the preparation of match boxes, then this particular lead oxide is generally used. This is generally not used in the paints as a pigment. White lead is used. Lead chromate is actually orange in color. This Pb3O4 is dark red in color. These three are generally used as pigments, but not PbO2. Therefore, question number 28, answer is E. Question number 29, tin reacts with concentrated H2SO4 to give alpha stannic acid, stannous sulfate, beta stannic acid, stannic sulfate, concentrated you said. Therefore, tin with concentrated sulfuric acid, stannic sulfate you are getting SnSO4 taken twice like this. Stannic sulfate you are getting. Therefore, question number 29, answer is D. Question number 30, iodine is decolorized by. Iodine decolorized by means a reagent should be a reducing agent. Now, ZnCl2, HgCl2, SnCl2, AlCl3. See, ZnCl2 saturated. How can it reduce? There is no choice of acting as a reducing agent by ZnCl2. Mercury chloride, HgCl2. Yes, it is highly saturated with +2 oxidation number. SnCl2 and AlCl3. Zn plus 2, Hg plus 2, Al plus 3, they are all actually saturated having what highest oxidation number. But SnCl2 can easily become SnCl4 also. Therefore, SnCl2 can make I2, to 2Hi in presence of HCl. Then the product is SnCl4 plus 2Hi. See here, iodine is actually converted into Hi, then iodine is actually decolorized. Therefore, question number 30, which can decolorize this particular iodine? Only SnCl2, the reducing agent reducing iodine to Hi. Therefore, question number 30, answer is C. See question number 31, if a person is injured by a shot of a gun, all the pellets could not be removed, it may cause a poisoning of. A is given as mercury, B is lead, mercury, lead, iron and arum. See that a bullet is actually the bullet shield. Bullet shield is actually made up of generally lead, copper and nickel. These are the things generally bullet shield is carrying. Then one of the bullet is actually entered into our body, that is not removed. The lead may cause a poisonous effect on our body because lead is actually a poisonous metal, you remember. Therefore, question number 31, answer is B. Question number 32. Litharge is not commonly used in manufacture of special glasses. Generally in the preparation of glass, PbO is used. Litharge is nothing but PbO. Litharge, PbO. PbO is used in the preparation of glass instruments, optical instruments. Therefore, manufacture of special glasses, yes. Glazing pottery, yes, it is used in glass. Therefore, to get a glaze for the pottery, we are using this particular PbO. Preparing paints, yes, PbO is a pigment because of the colored substance and we use this as a pigment. Lead storage battery, this is not used in lead storage battery. See, lead storage battery carrying PbO2, Pb and sulfuric acid. PbO2, Pb and sulfuric acid. The ultimate reaction is actually here 2Pb, SO4, 2H2O. This is generally a reaction taking place in the lead storage battery. There is no choice of any PbO here. Therefore, question number 32, answer is D. Question number 33. Producer gas is a mixture of CO plus N2, CO plus H2, N2 plus CH4, COH2 and N2. COH2 and N2. See, actually producer gas CO plus N2. And water gas, CO plus H2. This is what actually producer gas. Therefore, question number 33, answer is A. Question number 34. Silica reacts with magnesium to form a magnesium compound A. A reacts with the dilute HCl, forms B. B is. Silica reacts with magnesium. Silica reacting with magnesium, then you are getting Mg to Si. Mg to Si. This is our reaction with dilute HCl, reaction with dilute HCl. Then you are getting MgCl2. So, question number 34, answer is C. Question number 35, which of the following oxide is amphoteric? Given as CaO, CO2, SiO2, SnO2. See, every time a question on oxides, nature of oxides, classification of oxide based on nature of oxides, you have to remember different types of oxide, what is the nature of those oxides. Yes, CaO is the alkaline earth metal, basic. This is basic oxide. Alkaline earth metal, yes, basic oxide. CO2 non-metallic oxide, CO2 is actually acidic oxide. SiO2 also acidic, non-metallic, acidic oxide. SnO2 heavier metallic oxide, this is what actually amphoteric. Amphoteric oxide. Therefore, question number 35, answer D. Question number 36. The stability of dihalides of silicon, germanium, tin and lead increases steadily in the sequence. You will write the dihalides, silicon, chloride duty, germanium, chloride duty, SnCl2. Cl2. These are the halides, dihalides. All are having got plus 2 oxidation state, plus 2. All are having plus 2 oxidation state. But one thing you remember, in any group, stability of lower oxidation number increases top to the bottom. Stability of lower oxidation number increases from top to the bottom. Suppose you talk about silicon plus 2, less stable than JEE plus 2, less stable than Sn plus 2, less stable than Pb plus 2. Among all these plus 2s, this particular lead plus 2 is more stable. Top to the bottom, the stability of lower oxidation number is increasing. It is due to actually inert pair effect, you can call in the case of lead. Therefore, order of stability will be this is less stable than this. This is the order of stability. Coming to question number 36, answer is C, silicon, germanium, tin and lead. Therefore, question number 36, answer is C. Question number 37, quartz is an example of chain silicate, sheet silicate, cyclic silicate, 3-dimensional network silicate. Quartz is nothing but silica. Purest form of silica is quartz. Therefore, it is having a network of SiO2s. It is 3-dimensional silicate. Therefore, question number 37, answer is D.